Hey everybody, I hope you had a great day today and are ready to do some math. We're going to talk today about relations and functions. Okay. You're going to learn what the definition of a relation, a domain, a range, and a function is. You're going to learn how to display the relation and the function, and then you're going to learn how to determine if a relation is a function. Remember, at any time, if you need to, pause the recording, take a break, write down notes, just like always. Okay. A relation is just a set of ordered pairs. So here we have two sets of ordered pairs, -2, 8, 4, 2, 1, 3, -2, 4, and 3, 1, 5, 3, and 6, 6. The only definition they have is they just have to be a set of ordered pairs. They don't have to have a relationship. They don't have to have a rule to get from the x to get to the y. They just have to be together. Because this is a set, though, we have to make sure that we use the braces. The brace at the end and at the beginning, it signifies that these go together, just like we have to use parentheses to say that two numbers are ordered pairs. So how can you represent a relation? First, we can represent it as a set of ordered pairs, as shown here and as the first two examples were. From those ordered pairs, we can display it a variety of different ways. We can display it as a table, a mapping, which might be new to some of you, where a mapping, we look at the arrows. -2 maps to 3 by following the arrow. 0 maps to -2, and 3 maps to 1. Because we have ordered pairs, that means we can also represent our relation as a graph. And lastly, sometimes we can even represent these as an equation or a function rule. A relation is made up of two parts, the domain and the range. The domain is all of our x values in the relation, and the range is the set of all y values in the relation. You might have seen them used or called by these other names: input, an independent variable for domain; output, independent variable for the range. Remember that in a set of ordered pairs, or in one ordered pair, the x is the first coordinate, the y is the second coordinate. If I was to look at the domain of this function, my x coordinates are 3, 8, -4, and 5. Your teacher, meaning me, would greatly appreciate it, though, if you wrote these in numeric order. It gives us a common language when we're checking and we're talking about them. So if I put these in numeric order from least to great, I get 4, 3, 5, and 8. My range is all of the y values. And in this case, it's going to be -9, 2, 0, and -2. And again, I would love it if you put these in numerical order from least to greatest. So -9, -2, 0, and 2. So there's my domain and my range. In this example, we have a mapping. The domain is all of our x values. So -2, 0, and 3. Notice that I use the braces to indicate that it is a set. And then the range is -2, 1, and 3. I don't know why I keep trying to write the 3's as braces. Go ahead and write down the ordered pairs for this relation. Go ahead and pause the video and do that. I'll wait. Did you get -2, 3, 0, -2, 3, and 1? If I know you guys, every last one of you got it right. Great job. Okay. If you didn't, let's talk about it in class. Let's suppose that I want to take and add another ordered pair. Okay. Well, it changes, drawing the arrow from 0 to 1 and adds this ordered pair, it doesn't change the domain and range. Okay. Once a 0 is in that domain, it continues to be in the domain. Now that we've explored relations, let's talk about a function. And the big bad algebra definition is a relation where every input has exactly one output, or every element in the domain maps to exactly one element of the range. So if we recall, the domain is our x's and our range is the y's. So in order to determine if this is a function, we just need to look at our x values. As long as none of our x values repeat, then this is a function. So if I look at my x values, -2, 4, and 0, they don't repeat. This is a function. If I were to draw a mapping of this, -2, 0, and 4, and 3 and 8, -2 goes to 3, then 4 goes to 3, and 0 goes to 8, notice that there is only one arrow coming out of each x value. The second example, my 3's repeat. So if I were to draw a mapping of this, 3 goes to 1, 3 goes to 2, and 2 goes to 4. Notice that I've got 2 arrows coming out of my 3. Or in the case of the ordered pairs, the 3's repeat. This means that this is not a function. Okay. Lastly, if we have a graph, we can use a vertical line test to see if it's a function. So if a vertical line passes through more than one point of a graph, the graph isn't a function. So if I were to draw a vertical line through this, we notice that it intersects our graph both here and here. So this is not a function. Okay. Want you to think about why that is, and we'll discuss it more in class tomorrow. On this, if I take a vertical line and I keep drawing it through, it will only intersect our graph in one place at a time. So this is a function. And this last graph is from our earlier example. If I take a vertical line through each of my points, it will only hit one point. So this is a function. Hopefully today you learned what the definition of a relation, the domain, the range, and what a function is, how to display it, and how to determine if a relation is a function. I hope you jotted down any questions that you have so we can discuss in class tomorrow. Have a math-tastic day.